All right, ladies and gentlemen, welcome to the third and final part in our weathering series. We have so far covered all kinds of different types of mechanical weathering. And just as kind of reminder, you already have this in your notes, but mechanical weathering, of course, is physically breaking rocks into smaller pieces without the use of chemicals. All right. So now we are going to move on instead to chemical weathering. So you're going to start adding this to your notes on the second page. And chemical weathering is when chemical processes dissolve and decay earth materials or earthen materials. When chemical processes dissolve and decay earthen materials. All right, so chemical weathering can happen at different rates. Sometimes it takes a long time. Sometimes it can happen relatively quickly, and how fast it happens depends on a lot of different things. It can depend on temperature. Um, the warmer it is, the faster the chemical weathering happens. The colder it is, the slower the chemical weathering happens. Therefore, weathering of rocks tends to happen much more quickly in like tropical climates rather than in the tundra or in polar climates. Um, the amount of surface area. So there weren't too many of you who did the chalk weathering lab, the chemical weathering lab, but these are the types of things that you were experimenting with by using different temperatures of vinegar and water uh, to see how those dissolve. The chalk, the higher the temperature, the more dissolving you had happening. The amount of surface area makes a difference because then the acid or the chemical, whatever it may be, can touch a lot more different parts of the rock, or in the case of the lab, the different parts of the chalk. So whereas before it could only touch the outside of the rock or the chalk, once you break it up into pieces and there's more surface area, then now the chemical can get to more parts. And then finally, the availability of water or natural acid. So water and different acids are the chemicals that break down rock or weather rock. And so if it's a very dry climate with very little precipitation and very little water, then you're not going to have a lot of chemical weathering unless there happens to be a lot of natural acid around. But typically, if there's no water, there's not usually a lot of acids. There could be some. Um, Whereas, again, in tropical type places, you have a lot of water, you have a lot of acids as things are decaying and things like that. And so there's a lot more chemical weathering happening much more quickly. All right, we're going to take a look at a few different kinds of chemical weathering, kind of like we did with mechanical, not quite as many. The first one is known as carbonation. Usually, when we think of carbonation, we tend to think of soda, or in my case, maybe seltzer water. Um, Same basic idea. Seltzer water is water that has CO2 or carbon dioxide in it. Well, when water and carbon dioxide come together, it creates carbonic acid, which can wear down rock. The same carbonic acid would also be found in my seltzer or in sodas, and is part of what can also wear away at your teeth. Um, but uh, the mixture of water and carbon dioxide again creates this acid, carbonic acid, and that eats away at the rock. I don't know if you ever heard of Cleopatra's Needle. Uh, it is a monument, an obelisk monument, and it was originally built in Egypt. There were actually several of them. Three of them got moved out of Egypt where it was dry, not a lot of chemical weathering going on in Egypt. Mechanical, certainly, because there's, sand and dust and things being blown around, but not as much chemical. And so three of these obelisks were removed from Egypt and they were taken to three different cities, London, Paris, and New York. So we're going to take a look at what it looked like when it arrived in 1881 in Central Park in New York City and what it looks like more like today. So this is what it looked like when it arrived. It wasn't in great shape because it was an ancient monument. However, you can see today a lot of the carvings that were in there have worn away um, and been eaten away, okay, because you have a lot more rain in New York City than you do in Egypt, and you also have a lot of air pollution and chemical pollutions in the air. So you combine that together, you get acids that eat away at the stone that the monument was made out of. All right, our next type of chemical weathering is known as oxidation. Oxidation. It's the process by which oxygen combines with water. So before we had carbon dioxide combining with water. Now it's oxygen combining with water. And when it does, it and then that mixes with the minerals in the rock, it tends to weaken those minerals. And you actually get rust on rock. So rust comes from the combination of oxygen and water. It gets on the rocks and it rusts the rocks and kind of eats away at the minerals and weakens the rock. Here's another example of a rock that has rust on it. And here's another one, not too clear, but you can still see kind of the outline of some rust here around the edges. All right, quiz. Which picture best represents oxidation weathering? Which one do you suppose? Yes, that's right. It's letter B. Why the penny is there exactly? I'm not really sure, other than the fact that I guess the rust on the rock looks a little bit like the color of the penny, or maybe they were trying to show size. I'm not sure. It's a nice penny. All right, picture A actually shows us a little bit more of something we're going to talk about right now. Solution, the process by which minerals in rocks dissolve directly in water. So some of the minerals that make up certain rocks are quite soft, and they are minerals or substances that have a tendency to dissolve in water. Not all minerals dissolve in water easily, sometimes not at all, but some do, and some rocks are made up of a lot of these minerals, and so when they come in contact with water, they start to dissolve, or at least parts of them do. And that's part of what helps to create limestone caves. I don't know if any of you have had a chance to go into any limestone caves that have all kinds of stalagmites and stalactites, um, but as the water reacts with the soil and absorbs the carbon dioxide, it of course becomes mildly acidic because we know it forms carbonic acid, begins to wear away the rock. It starts to, then water starts to drip down through and it carries other minerals with it. And you get all these fun looking formations inside the cave. All right, some other examples of uh, also include organic acids, so acids that exist naturally in the soil, and they come from not just from the soil, but they also come from lichens. So lichens are these little tiny, well, sometimes we call them plants. Technically, they're not plants. Technically, they're actually a fungi and an algae that are living together. And they like to live on the surface of rocks. They also like to live on trees. But the the lichen actually release acid. I guess we all do really as waste products, but they release acid. And so when they are on these rocks, the acid starts to wear away at the rock after a while. You see it a lot on old gravestones, in old cemeteries. Maybe cemetery walk is if you have one within walking distance of your house, might be a good place for some social distancing. You can look for some lichens. But part of the reason that those stones, those gravestones, get worn away and you can't see the engravings on them as well anymore, sometimes is because of the acid from the lichens that are living on there. Sometimes it's also because of, the acid rain that we talked about a few minutes ago. Here's a close-up of lichen living on the gravestone. And a close-up again, zooming in right there. We've got some pink granite here that has a bunch of green lichens growing on it. Those lichens are going to give off acid and over time wear away the rock. Another thing that can cause chemical weathering, salts. Salts are chemicals. There are lots of different kinds of salt. The salt we usually think of is table salt, sodium chloride, NaCl. We talked about that back in our ocean unit. But there are lots of different kinds of salts. The salt that we that we scatter outside on the ice to melt the ice is a different type of salt. So there are lots of different chemical salts, but they can also cause the minerals to weaken and start to wear away. And then there's human pollution. Human pollution usually ends up releasing a lot of carbon dioxide into the air. Then that carbon dioxide mixes with the oxygen, mixes with the water. We have the carbonic acid, which falls down and damages a lot of not just rocks, but also monuments and things like that as well. All right, ladies and gentlemen, next week we're going to very briefly take a little bit of a look at the Old Man in the Mountain. Um, and then move on to erosion and then deposition. All right, have a great weekend.